variables. So there are different types of variables. We've got numeric variables or quantitative variables, and these can be continuous or discrete based on whether or not the variable can take on infinite number of values or only non-negative whole numbers, respectively. And then we've got categorical variables, and these can be either ordinal, meaning they have some kind of natural ordering, or not. And so these are kind of the types of variables within as a computer would recognize them. And so visualizing numeric data. So describing the shape of numeric data, describing the shape of numeric distributions can be really important. So the different ways that numeric data could be shaped, we could have skewness, meaning it could be right skewed or left skewed or symmetric. And just this is, I find, always really hard to remember, but skew is to the side of the longer tail. So if it's right skewed, then it has a long right tail. If it's left skewed, it has a long left tail. If it's symmetric, it's not skewed. Another term to describe the shape is the modality, and so it could be unimodal, bimodal, multimodal, or uniform. So unimodal distribution will have basically just one mode, so kind of one bump. If you're thinking about kind of a normal distribution, that would be unimodal. Bimodal would have two modes. Multimodal could have multiple. Uniform is going to be just straight across all the way. The other way to describe numerical distributions are by the center, so the mean or the average, the median, and the mode. Another way is the spread, and so this is going to be like the range of the data, the standard deviation or the variance of the data, or the interquartile range. And then finally, it's nice to describe unusual observations. So a histogram is a nice way to basically be able to visualize your numeric data. And so you'll notice here, I still am using my ggplot function. I'm specifying my data. But now in my aesthetic mapping, I'm only specifying an x variable, height, to map. And that's because histograms only take a single variable, and then it plots based on the distribution of that variable. So now underneath there, I've got a geom here, geom histogram, to indicate that I would like to create a histogram. Here's an example of a density plot. What changed between the histogram and the density? The geom. So the top part stays the same. I'm still looking at height here, but my geom changed. And so now instead of looking at a histogram, I'm looking at a smoothed density of this variable. Another way to look at things could be side-by-side box plots. So box plots are great if you're looking at a continuous variable, but you'd like to look at it across a number of discrete or categorical variables. So in this case, I'm looking at height on my y-axis here. So I'm still looking at height. I'm still interested in the distribution of height, but I'd like to look at it across different genders. And so my x here is gender. I see my height for my feminine, height for masculine, and height for missing. And in order to specify that I'd like to use a box plot, I use geom box plot. It's good practice when you're doing a box plot to always actually show the underlying data. This can be really important because sometimes you can have a box plot that sort of looks one way, but once you see the data points themselves, it tells a little bit of a different story. And so to do that, I include this geom_jitter function, and that's going to put points and it's going to kind of jitter them a little bit. Otherwise, you'd end up with points all on top of each other in a line. There's one extra piece here, this outlier.shape equals NA. And the reason you need that is, if you notice here, when I plotted the box plot, by default, it plots these outliers here, these points. And if I'm jittering, I don't actually need those points to be plotted. And so I can set the shape to missing so that it doesn't plot those and just rely on the jittering to cover those external points. So the big takeaway here is the importance of showing your data. That's what that jittering is for, and that is always very, very important. Okay, so let's talk about visualizing categorical data now. So the main way to visualize categorical data is going to be via bar plots, and you can do that with geom bar. And so here, this first ggplot function is going to be the same as we've been working with before, except now instead of mapping to a numeric variable, I'm mapping a categorical variable, gender. And then I just set geom bar to indicate that I want to have a bar plot, and it's going to create this count here across each of my categories of gender. You can have bar plots that are filled by different categories. For example, here, I still have x equals gender, but I'm telling my bar plot I want it to be filled by this additional categorical variable, hair color. And I still use geom bar. So what that's doing is within each of these bars, I have a different color for each of the different hair colors. And so for the counts for them, they all sum up to the total, and but I can see it kind of broken down by this categorical variable. This is called a segmented bar plot. If you instead are interested in the proportions instead of the absolute count, you can change the geom bar position to equal fill. And so what that's going to do is it's going to basically fill this whole space so that these all are adding up to 100. So it'll look at the full proportion within each of these categories, and it'll let you compare kind of between them. So this is nice if you're trying to compare kind of like if you want to know, among the females, are they more likely or less likely to have brown hair compared to the masculine gender? And it looks like here, because there's a larger proportion in the female category compared to the male category, that we could draw that claim. Okay, so which of these do you think is a better plot or a more useful representation for visualizing the relationship between gender and height? This gets back to that show your data piece. If we just use a bar plot to be able to show the relationship between height and gender, we really mask a lot of information. It doesn't give us a good sense kind of what's going on. It only tells us the average. And it's also kind of hard to tell the difference between these because we are they don't look that different. Whereas this plot down here, this box plot that has the jittered points, now if it was bigger, it would be better. If I had a bigger slide and could make it sort of larger, of course that would be better. But this actually gives us much more information because it shows us the actual data points. And if we were able to zoom in on it a little more, like we could here, let's go back to the original one where we showed that. Yeah, so here's the bigger version of that plot. And it's nice because box plots give us more than just the average. It gives us information about the interquartile range. It gives us information about kind of the spread of the data in a much more appealing way than just a bar plot. So anytime you're doing anything with numeric data, even if you're faceting or even if you're looking at it across a categorical variable, it's important to pick something that actually shows that underlying distribution.